Last time, I demonstrated the outline of the tool changer door mechanism. In this episode, I will test how to create coiled cables based on my requirements. Hi, welcome to Slow Engineering. I'm David. I realized I could customize my coiled cables, which was a good indication for personalizing the switch cable. The winding parts helps compensate for the movements of the floating bar, and the remaining straight parts is for wiring outside the door. Based on my information, only specific cables are suitable for coiling. Cables that can be thermally formed are the ones that can be coiled. The optimal solution for this application is to utilize the cables with sensors. Different wires can be connected if the original sensor wires do not work. It is essential to determine the specifications for coiled cables. Based on the current design, the width of the space is approximately 12 mm, meaning that the coiled cables should be at most 12 mm in diameter. The sensor cable has a diameter of 2.5 mm, resulting in the winding sections being at most 7 mm in diameter, allowing for some tolerance to ensure a better fit. I chose a bar diameter of 6 mm for coiling the cable. Once the bar has been chosen, it's time to calculate its length to determine how much the coiled cable can compensate for the entire movement path of the floating bar. The lowest position of the floating bar is 51.38 mm from the bottom, which is the maximum length for the coiled cable in the shrinkage stage. The total moving length of the floating bar is 368.62 mm. With a 2.5 mm diameter cable and a 6 mm bar, the length of a spiral circle is 6 times pi. Considering the 2.5 mm thickness and the 51.38 mm limit, the maximum number of the coils is 20. These 20 coils gives a cable length of 377 mm, close to the target length of the 368.62 mm. However, this tight coil numbers could cause the coiled bar to stretch into a line. Adding extra coils can prevent the coils from straightening. Therefore, I have decided to have 2 extra coils on the bar, bringing the total to 22. The sensor has a 12 mm clearance to the floating bar edge. To achieve this, I use a 6 mm stainless steel rod. First, I tape the cable, leaving 2 mm for the sensor outside the rod. And then started coiling the cable. When coiling the cables, I kept it close to the rod and stuck it cycle by cycle. After completing 22 cycles, I taped the other end of the cable to fix it onto the bar. After preparing the coil, use a heat gun to heat the coil part, avoiding heating the sensor. After heating, spray water onto the cable to cool it, then leave it to cool down completely. Then loosen the cable and remove the rod. Some coils might stuck together, so separate them to make individual coils. You will notice that the coils are rather loose. Reversing the entire spiral part is the key to making the coil spring. Once you have reversed the coil, it should return to the shortest stage. Luckily, the original sensor cable can be coiled into a spiral shape. Next, I'll assemble the prototype to assess the design. As always, moving forward.